Check one, welcome. Test one, check.
Yep, sounds good to me. Okay, I think we're ready to go then.
Time to start?
Yep, it's time to start.
All right, here we go. Hey, welcome everyone to our Sipping Ground Sipping Ground Coffee Summer Series of live stream broadcast. My name's Dan Painter, and I'll be hosting today's broadcast. There's a variety of topics that we'll be talking about over the next 3 months, and the marketing team here at Flint & Walling has decided that if you are able to provide proof of attending at least 3 of these sessions, there's going to be some type of a reward or given for that. And the way that that's going to take place is somewhere between now and the end of this presentation. I'm going to give you a code word. And that code word will be something that you'll email to Flint & Walling. And that email address is marketing@flintandwalling.com. So you send that code word in, you'll get credit for today and any future broadcasts that we may have. So again, if there's any questions as we go through today, don't be bashful, don't be embarrassed to ask, and we'll see what we can do. I don't have anything up here on my screen, Renee, over here on this side. And okay. This is our second broadcast. So, hey, that's looking better. It says getting set up. I'm going to advance this presenter once and see if that advances the slides. There we go. All right. So today's topic is Irrigation Pumps 101. Unlike the counterpart submersible pumps, we are going to be talking about what a lot of people would categorize as above ground pumps, right? So these pumps are all going to be installed on solid ground. They have air-cooled motors, but there are a variety of these that are used within the irrigation industry. So to start this off, we're going to talk about basically 2 types of above ground pumps. That first one is referred to as jet pumps. Jet pumps have been around for a long time. In fact, back in the 40s, 50s, if you had a house in the country, you probably had a jet pump providing water for you. But that's the first of the 2. The second one is what we call centrifugal pumps. I want to focus on jet pumps just for a little bit. These are, when used for irrigation, jet pumps, the water source is typically either going to be a well or a cistern of some type. That would typically be the water source for a jet pump. If it's a well, I need to advance this. It says getting set up again. It's not moving my slides forward. There we go. Okay. When talking about a well, all right, when a well's drilled, there's a water level inside that well casing, and this thing's just not advancing. It keeps saying getting set up. I'm not advancing slides like I would like to.
Yep, there you go.
All right, there we go. All right, so this water level that's inside this well casing, it's referred to as a static water level, okay? What that means is that's going to be the level of water in the well under non-disturbed, non-pumping conditions. And that can be easily measured from the surface down. And if that is less than 25 feet, or 25 feet or less from the surface down to the water source, if that's the case, then that is going to be referred to as a shallow well. That's an industry standard. And by the way, these above ground pumps that we're going to be talking about today, they cannot lift water more than that 25 feet threshold. Now, there is if that water level is further down than 25 feet, in other words, if it's more than 25 feet, the industry will refer to that as a deep well. All right, so this was important to know, particularly for jet pumps. It was important to know whether you had a shallow well application or whether you had a deep well application. And again, this was really only pertinent to jet pumps. And the reason behind that is that there's 2 types of jet pumps, all right? And that's the one type is 2 types of jet pumps, all right? Maybe have a slide or 2 out of place. Anyway, let's start off this way. You know, so I've been asked this in classroom before. you know, why do they call a jet pump? And I had a guy sitting in the back of the classroom one day raise his hand, and I said, yes, sir, why do you think they call a jet pump? And he looked at me and he said, well, let me ask you something. Have you ever heard one run before? I'm thinking, yeah, like several hundred times. Why? He said, well, they sound like a jet when they're up and running. And I'm thinking to myself, sir, we balance all of our rotors, we balance all of our impellers here at Flint and Walling. Not talking about our brand, because our brand's probably quietest pump in the industry. So no, that's not really the reason why they call a jet pump. I'll tell you why I think they call it a jet pump, at least this is an opinion, and that is because every jet pump is going to require what is referred to as a jet. Some old timers would refer to that as an ejector. But that's, you can see those up on your screen. There's two types of jets. The one at the top is what's called a shallow well jet. That thing bolts right to the front of the pump. If you look at that top left picture of that pump there, you can see that jet's bolted right to the front of that pump. That's a shallow well jet. The other one is a deep well jet, and that is going to be mounted vertically. And a lot of times that's going to be in the well much near the water source. But these are the two types of jets that accompany a jet pump, which is, I believe, the reason they call them that to begin with, the jet pump, right? All right, let's look at that shallow well ejector, the deep well jet or ejector. Again, the application is going to be pertinent on how far is it to that water source.
Here, Dan, let me try to get that getting set up off of you real quick.
All right. Yeah, I see that getting set up on there. I don't know if that's coming on the live stream or not.
I think it is. That's why I'm trying to fix that for you.
Okay. Should I wait on you, or should I just keep rolling?
Oh, just keep going.
All right, I'll keep rolling. All right, so how do they work? All right, let's talk about how does a jet pump, how does it work? Everybody's had this experience before in their lifetime, right? We've all held a piece of garden hose and we've watched water roll out the end of that rascal, and sometimes, you know, if they've got a lot of pressure, that water will shoot out there, what, 5, 6 feet, maybe 7 feet, something like that. In fact, that was my primary source of drinking water when I was a kid growing up. So we've all had this experience, right? Water's going to come out of there. It's going to roll out the end of that garden hose. And like I said, it's going to go out there, what, 5, 6, 7, 8 feet, all right? But what happens when you do this? Well, that changes everything, doesn't it? That changes everything, because now that water is going to be shooting out, you know, several feet. You can probably shoot it out there 30 or 40 feet. So what happened is when you put your thumb over the end of that garden hose, all right, what happens is you've increased the velocity of that water coming out of that garden hose. You've restricted that opening, and so now that velocity of that water coming out of that hose is going to go out a lot further than it would be if it were simply just rolling out the end of the garden hose, all right? Now, that said, velocity is going to result in something here, and I want to show you what it's going to result in. In fact, this is a science fair project I did several years ago for, I don't know if it was my son or my daughter. Let me explain to you how this whole thing worked. I had a piece of 3/4 inch copper, and I pressed a nozzle inside of that copper tubing, all right? I pressed a plastic nozzle in there because I wanted to mimic holding your finger over the end of that garden hose. So I put a nozzle in there. And then just ahead of that nozzle, I drilled a small hole and soldered in a small piece of copper tubing. All right, so this is kind of like a Y look to it. I also soldered on a hose bib fitting on the end of that thing. We walked this out to the backyard, hooked the garden hose up to it, and turned the garden hose on, all right? So when we turned that garden hose on, all that water come rushing into that little piece of copper tubing until it got to that nozzle. When it got to that nozzle, the same thing occurred that occurred in the previous slide. By restricting that opening, we created a large amount of velocity, all right? So a lot of velocity coming out that thing. That thing was shooting way out across the yard. Here's the lesson. I asked again, I don't know if it was my son or daughter, I asked him, I said, I want you to put your finger over the end of that tube, all right? Go ahead and stick your finger up there once. And I asked him, do you feel anything? Oh, they were shocked, right? Oh my gosh, yes. They said, hey, Dad, it's wanting to suck my finger right down into that tube. That's exactly right. Because what happens is that velocity that's moving out through that nozzle creates a pulling effect or a suction effect behind it. I'll give you an example. This may be a little old school, but if you were running down a highway and all the windows in your car are rolled up and somebody fired up a cigarette, after about 2 or 3 puffs, that entire compartment's going to be filled with smoke, right? Yes. Now, what happens if you don't need to roll the window down, just crack it a little bit. What happens to that smoke? Well, you'll see that smoke's being pulled out of that small opening in that window because of all that velocity of air that's moving past it. And again, that creates kind of a pulling effect. And so when we look at these jets, and again, whether it's a shallow well jet or whether it's a deep well jet, they're both going to have nozzles inside of these jet assemblies, all right? Let's look at how this works. If you look at this pump that's on the screen, the front of it's got 2 openings, which is where that jet's going to mount to with a couple of bolts there. You can see how that works. What a lot of people don't know, though, about jet pumps is this. They don't know that a portion of that water that pump is pumping is not going out the discharge. It's not going to the house. It's not going to the irrigation system. A portion of that water that pump's going to pump is going to come out that bottom port of that in the front of that jet pump there. Well, when it comes out that bottom port, guess what happens? It's going to go directly into that jet and it's going to make a U-turn, right? It's going to make a U-turn and then we're going to run that water through that nozzle. And when we do that, that's going to create that suction, all right? That's going to create that suction that's going to have the ability to pull water up out of the well or pull water up out of a cistern, all right? That's basically how it works. Very, very simple operation. You see that plug in the front of that jet, the little pipe plug up there in the front of that jet assembly? Let me tell you why that's there. If somebody came up to me and they said, "Hey, painter, my jet pump's not performing very well. It's only pumping very little, if any, water at all. What do you think may be wrong?" Well, the first thing I would recommend is look at that nozzle, check that nozzle out, make sure that it's not plugged or partially plugged. Because if it's got debris lodged in it and it's partially plugged, then you're not going to get the velocity required to create the suction to pull water up out of the well or the cistern. And so that plug is there, that clean-out plug is in the front of that jet assembly so that you can go in there with a piece of stiff wire or copper wire and perhaps dislodge anything in that nozzle without taking that assembly off the pump itself. On a deep well jet, like I said, that jet's going to be mounted down in the well, closer to that water source. So what we have to do with a deep well jet then is we've got to come out with that bottom port where that pump's pumping water out of there. We got to run that line all the way down to that jet, all right? And that could be several feet down. In fact, a deep well jet pump, you're probably going to get away with pulling water from a depth of maybe 90 feet with a deep well jet pump. But we're going to run this water down one pipe into that jet, which is in the well, so that we can make that U-turn and run that water through that nozzle. And that's where that suction's going to get created, all right? So then we're going to bring the water coming out of that jet into the top portion of the front of that pump. But that's the difference between a deep well jet and a shallow well jet. And in the spirit of full disclosure, these pumps that are up there on the screen right now, you can see that the one on the left is set up to be a shallow well jet pump. It's got the jet bolted right to the front of the pump, where the one on the right's got the 2 openings in the front, and that you could run that to a deep well jet. These pumps are referred to as convertible pumps, all right? So you've got big visual difference. And one of the things I want to try to accomplish in this brief presentation is that you can look at a pump, just visually look at it and determine what type of pump it is without having to look at a model number, without having to go to a catalog. Just look at the pump. And by a visual inspection, you'll tell which type of pump it is. For example, you've got a shallow well jet pump. You got one pipe running to the water source. That's it, just the one pipe. With a deep well jet pump, as we discussed earlier, you'll have 2 pipes running to that water source. On all above ground pumps on the bottom of the suction line, whether it's a cistern, a lake, a well, what have you, on the bottom of the suction line all above ground pumps, you need to have a foot valve, and that's what's being pictured on your screen there. It's very similar to a check valve. It only allows water to go through it in one direction only. There's a fine mesh screen wrapped around the bottom of that so that it keeps any debris or large particulates from getting in, particularly on a jet pump where it could lodge in that nozzle. But that foot valve's important. And as I mentioned just a minute ago, a lot of these pumps are referred to as convertible jets, all right? Convertible jets. What do you mean by that? Well, a lot of suppliers loved this back in the day. They could stock one pump and two jets. If they stocked a shallow well jet, they could send that out with the pump, and the installer could bolt it to the front of the pump, and they made a shallow well jet pump out of that. Or they could send that pump out with a deep well jet, and the installer would then plumb that in, and they would make a deep well jet. So they could stock one pump and two jets. Now, there are applications where it would be, shallow well only, and we've talked about the difference between shallow and deep well. So when it's a shallow well only jet pump, all right, look at the front of this pump casting. There's your jet. It's mounted there. You'll see the clean out plug in the very front, but that jet is actually a part of the casting. It's an integral part of that casting. That can never be changed. So that pump that I've got up on the bottom side of that screen, that's a shallow well jet pump. It'll always and only be used for shallow well applications. Anyway, there's your jet pumps. All right, so the visual difference and the way we decide what's the difference between a shallow well jet pump and a deep well jet pump. Shallow well, the water source needs to be 25 feet or less, and a lot of times this is referred to as a single pipe system, right? One pipe running down to the water source. Whereas we look, well, just before we get to the deep well jet, I want to talk about this water source. You see that on the screen here? That distance between the water level and the well, it could be a cistern or a lake, it doesn't matter. That distance from that water level up to the top where the suction line's located, that's what we have to require that pump. That pump's going to be required to lift that water, that distance. And there's where you're going to measure whether it's more than 25 feet or less than 25 feet. And I had a guy call me out in class one day. He said, wait a minute. He said, why are you stopping at the water level? Why don't you go on down to that foot valve, which is several feet below that water level? He said, that's where the water's coming in. And so isn't the pump having to lift water from that point? No, it's not. And I don't know if this next slide, yes, here it does. This is, I had to show him this as an example, but if you take a glass of water and you fill it to the top, and you drop a straw in the glass of water, and I looked at him, I said, sir, where do you think that water level is inside the straw? He said, well, that's easy. He said, it's at the same level it is in the glass. I said, you are absolutely right. And when you put your lips on the top of that straw and you begin to pull that water out of there, you're not having to lift it very far because it's already that far up inside the straw. The same thing applies over here in the well. When you drop that drop pipe down into that well, that water is going to enter that foot valve and it's going to seek its own static water level inside your drop pipe. And so that lift is, again, it's only from the water source up. A deep well jet pump, here's the difference is that's going to be more than 25 feet, but the real visual difference between a shallow well jet pump and a deep well jet pump is how many lines are running to the water source. Therein lies the answer. If it's just one line, that's a shallow well. If there's two lines, that's a deep well. And by the way, if you're sizing up a jet pump just for a house, this is a very, very easy way to determine how much water does a household need. This is referred to as the fixture count method. It's been around for decades, many, many decades. And a lot of contractors use this to this very day to determine how much water is required. And it's called a fixture count, all right? So let's look at this house. Down in the bottom left, that kitchen down there, there's a sink and a dishwasher. That's two fixtures. We've got a laundry room, okay? There's a clothes washer inside that laundry room. And then upstairs is a full bath. There's a tub shower, a lav, and a toilet up there. So that's three fixtures. Downstairs is a half bath. So you can see where we're going with this. We're just simply adding up all the fixtures in the house. And then we also want to add up outside hose bibs, and there's one of those, all right? I don't care about ice makers, coffee makers. I don't care about that piddly stuff, but any water-using appliance like dishwashers, clothes washers, you do want to take those into account along with the other fixtures. And when you add those all up, you come up with 9 fixtures, and the fixture count method indicates that the total number of fixtures in the house should equal the gallon per minute rating of the pump. And so therefore, we're going to look for a pump that can put out about 9 gallons a minute. So that's how you could size up a jet pump for just a regular household application. All right, let me check, see where we're at on time here. Okay, I'm going to pick this up a little bit. We're going to get into the more popular above-ground pumps for irrigation, and that's centrifugal pumps, all right? There's 2 types of those as well. The one on the left is referred to as a straight centrifugal pump, all right? Straight centrifugal pump. And the one on the right, here's your code word, folks. Here's your code word. The one on the right is referred to as a self-priming pump. For some reason, my clicker just stopped again.
Yep, I put the word up there for you.
You did?
The self-priming, yeah.
Okay. Self-priming, there you go.
Yes.
Self-priming. There's your code word for today's session. Anyway, those are the 2 types of centrifugal pumps, straight centrifugals and self-priming centrifugals. My clicker's still not working. There we go. All right, self-priming centrifugals, all right? Let's look at the straight centrifugal first. I guess before we go there, let's look at the water sources. And here's where above ground pumps can really, the applications can vary from submersible pumps, because with above ground pumps, your water source can be a well. It can be municipal water, city water. There's a lot of applications where these pumps are simply acting as booster pumps on a city water supply. They can come from underground tanks or underground cisterns. Keep in mind, though, that water that's stored in a cistern or an underground tank, that's not going to be potable water, so that water would be used simply for irrigation only. There are applications across the country where they have above ground tanks. These tanks can store a lot of water above ground, and so therefore you got to have a pump to pull the water out of there and repressurize the system, and so those are applications. And then any number of surface water supplies, but any number of these sources can function on these above ground pumps. Centrifugal pumps, centrifugal force, all right? You're on the YouTube channel right now. If you'd like, you can go to YouTube and type in motorcycle and merry-go-round, and you'll get to see a couple of video clips of some young fellows that got to experience centrifugal force in a very personal way. Centrifugal force wants to throw everything to the outside, right? Everything goes to the outside. And so when water comes into an impeller, right, that same thing's going to happen. That impeller's turning at the rate the motor is spinning. And so when the water comes into the eye of that impeller, that's going to throw all that water out through those veins on the side of that impeller. We've seen this before. This is a satellite view of a hurricane. And as that hurricane intensifies and strengthens, that cloud formation moves further and further and further away from the center portion of that hurricane, that little black center portion, which is referred to as an eye. And like I said, impellers all have an eye too, right? They do. And when you put this impeller in a pump and you're pulling water from a water source, and that water enters the eye of that impeller, and that impeller is spinning at the rate the motor's turning, all that water is being thrown out those veins. Again, everything gets thrown to the outside. And when this is in a pump housing, it makes it very, very simple to transfer that water right on out of discharge. And now I'm going to tell you something. In my opinion, at least, these centrifugal pumps that we manufacture are probably one of the most simplest pumps that we build here at F&W. Very, very simple. You do have a choice of impellers, and not every pump company offers that, but you do have a choice of impellers when it comes to centrifugal pumps. You can get a thermal injected plastic molded impeller, very popular. It's, we own the injection molding company that molds this for us. And then the other one is a no-lead brass impeller, right? Those are a choice. There's not a whole lot of difference between performance, and there's not a whole lot of difference in the longevity, quality of these things. It really is boiled down to more of a choice. I would tell you this much, that all bronze impellers that we put in centrifugal pumps here at F&W, we are going to balance those 100%. Anybody that's ever had a chance to come up to our factory and walk through our factory out there, they'll see this process. They see we do a lot of balancing out there, but all these impellers are going to be balanced. That's why I said, when the guy said, well, did you ever hear a jet pump? Yeah, well, no, not ours. Speaking of impellers, the more impellers that a pump has, this is just pretty generic information here, the more impellers that a pump has, the more pressure that pump's going to produce, all right? That pump's going to produce more pressure with more impellers. Impellers are oftentimes referred to as stages, and as you can see, centrifugal pumps, you can purchase these either in a single stage or multi-stage, 2 or 3 stages. I had a guy come up to me after class one day. He said, Mr. Painter, I learned something today. I said, what'd you learn? He said, well, I didn't know they called impellers stages. He said, I've got these pumps back in my warehouse. He goes, I've seen it. He said, this one says 2 stage, this one says 3 stage. I didn't know what that meant. He said, now I do. It means impellers. And sometimes I get asked, when do you use a 2 stage or a 3 stage over a single stage pump? When would you use that? Well, like I said, the more pressure is created by increasing the number of impellers, okay? So if you have a pump, can we shut this door over here? That's a little distracting for me. I'm going to just shut this door over there. I'm hearing noise out there. So if you have a pump that sits way down here at the base, thanks, Renee, and you're trying to get water up here to the top of that hill. Whoops, there we go. All right, there we go, right there, perfect. It's going to take a little more pressure to get water up there. So oftentimes, multi-stage centrifugal pumps, oftentimes they're going to be sold and applied in areas where you have a lot of terrain change or you've got elevation change, and you've got to overcome that elevation in order to get the water to the zone that's going to require that. And so oftentimes when that is the case, again, terrain change and elevation change, you got to have multi-stages to do that. Well, right here's a picture of where I live. This is Northeast Indiana. We're flat as a pancake. We sell a lot of single-stage pumps in this marketplace, and I'm going to tell you, we are so flat. How flat are you? I'll tell you how flat we are. I had a dog run away from home when I was 9 years old, and 3 days later, I could still look out there and see him. That's how flat we are. Anyway, that's where you're going to find the differences primarily between the single-stage centrifugals and the multi-stage centrifugals, is if you have to overcome elevation or terrain change. Here's a picture of a multi-stage centrifugal. There's 3 impellers inside this. Tell you a little story about this. I was at an irrigation show one day. I'm going to try to make this story quick. And a contractor walked in to this open house that they were having, and he walked up to my table that I had this pump on display, and when the guy saw that there were bronze impellers inside this centrifugal pump, I thought he was going to wet his pants. This guy got so daggone excited. He pointing at those things. He goes, my gosh, those are brass impellers. I said, yes, I'm aware of that, sir. He said, well, I didn't know any pump company used brass impellers anymore. I said, well, you got a choice with ours. You can have plastic or brass. He goes, well, I think that's going to solve a problem I'm having. I said, well, what kind of a problem you having? He said, well, just north of us is a great big lake up here. I think it was called Lake Geneva or something like that. He said, I got irrigation, not yours. He said, but I've got irrigation pumps, centrifugal pumps all around that lake, and they're pulling water out of that lake for irrigation purposes. And every season, I assumed he was talking every year, but he said, every season I got to go out and replace all these plastic impellers. He said, they're just in shreds. And I said, dude, something's causing that. He goes, oh, I know what's causing it. I said, well, want to share that with me? He said, sure. Shells. I said, you mean like a seashell? He goes, absolutely, shells. He said, they get inside that pump body, and as those impellers turn, he breaks these shells all to pieces, and they become very abrasive, and all of a sudden, they just shred my plastic impellers to no end. He goes, I reckon those brass impellers will hold up a lot better, won't they? I said to him, look, you're pulling water out of a lake. Yep. And you're getting shells inside this pump. Yes, sir. He said, I get a lot of them. I said, well, listen, on that suction line, don't you have a foot valve? Oh, yeah. I said, well, that foot valve's got a screen on it that's supposed to keep all this large particulate out of that pump. My guess is that screen's come off. You go, no, it isn't. He said, that screen's on there. I've checked that multiple times. I said, then can you explain to me how a shell is getting through the little opening in that screen? He goes, yeah, it's coming through as larva. larva, he said, is coming through. And it gets inside that pump body, and an irrigation pump may not be running every day like a home well pump. He said it could be gone weeks before it runs, depending on the weather. And he said as those larvae mature and they become zebra mussels and they get all tuned up, he said, I reckon those brass impellers will work a lot better. And I said, I don't know. We've deadheaded that pump for 30 minutes. We've pumped it against a closed valve, and that's a destructive thing for most pumps. Most pumps won't make it through an hour. We do that for 30 minutes. Most pumps won't make it through 30 minutes. We do it for 30 minutes 3 times. We run this pump dry for 4 hours. I'm not sure there's a pump out there that make it through 1 hour because of the construction, all right, the brass impellers. And I told him, I don't know how they're going to work on shells, but if I had your track record, I'd probably be willing to roll the dice, which he did. I saw him a year later. He come walking up, different attitude this time, big old smile on his face. He said, do you remember me? I said, sure do. My clicker's not working again. It looks like I turned it off. I said, you're the guy that had all the shells. He said, yep. He said, I said, what'd you do? He said, I put your pumps in. I suppose you used the brass impellers? He goes, absolutely. I said, and the verdict? He goes, nothing. I said, those things are working great. Anyway, centrifugal pumps, we're winding down here. They're the simplest of all pumps that we manufacture. But keep in mind, these pumps, these above-ground pumps in particular, the impellers will not move air. So they all have to be primed prior to installation. And that's going to take us to this last of the centrifugals referred to as a self-primer. All right? And again, even though this is referred to as a self-priming pump, all pumps, and I was taught as a young kid that all means all, and that's all means. All pumps need to be primed initially in order to function. And so I guess, you know, why they call that thing a self-primer then? All right, here's why. If we had these 2 centrifugal pumps, one's the straight centrifugal, the other one's a self-primer, and these were installed on an irrigation system, all right? And the irrigation system had a leak, and that's not uncommon. So there was a leak created somewhere, and overnight, that system drained completely down, the pressure went to 0, and I suppose, depending on how or where this pump is located, this straight centrifugal here, it would be possible for that water to drain all the way down to the bottom portion of that suction port there, that inlet port. Just below that little yellow hash line, it'll retain that much water in there, but everything above that's gone. Unless you take that drain plug out at the bottom, it'll retain about that much water inside that pump, which means the majority of that impeller is exposed to air. And so you're going to have to reprime a straight centrifugal pump so that that impeller is fully submerged in water. You're going to have to fill that suction line all up with water again. You're going to have to reprime that pump once you find the leak and fix it, all right? What happens if this were a self-priming pump and it drains down? Well, if it did the same thing, it could drain down to that yellow line. That's where your suction's at. So there's your visual between a straight centrifugal and a self-primer. On a straight centrifugal, the suction port, the inlet, is going to be right dead center in the front of that pump. They may call it a straight centrifugal because the water coming in is going to go straight into the eye of that impeller. That may be the reason they call it that. Whereas a self-primer, that suction port is way up high. You see that? It's way up high. So there's a visual difference right there. And so if we had these 2 pumps sitting side by side, knowing that the self-primer's got the high suction port or inlet, that's how you tell a self-primer from a straight centrifugal. But in the case of a self-primer, if the irrigation system springs a leak and it drains down, it's going to retain water inside that pump body. How much? Well, enough to keep that impeller submerged. So therefore, it's already primed. You find the leak, you fix it, and you just power the pump back up because, again, the impeller's already submerged in water, it's already primed, and that's where it gets its name, self-priming. And I'm going to end this session today just talking about priming a little bit. If you look at pumps, there's your suction up front and your discharge. Some pumps, not all, but some will have a dedicated priming port, all right? It'll be an additional port at the top of that pump. Typically, it's going to have a pipe plug in it that can be removed, and you can drop a funnel in that, and that is a way of priming this pump, all right? Now, if you look at this pump, that jet assembly, on the very top of that jet assembly that bolts to the front of that pump, there's also a plug up there. That's called a priming plug. take that out when you're priming the pump up. You'll find that that system's going to prime faster for you because it's got a place for the air to escape out there, right? If the pump does not have a priming port, and a lot of the centrifugal pumps don't, if I'm the installer and I'm going to install one of these pumps, I'll create a priming port by simply installing a T on the discharge side of this pump. I'll put a plug in the top of that T. Now, I've got a priming port, right? So if down the road I've got to come back and reprime this thing for whatever reason, all I need to do is pop that plug out of that top of that T, and I can go ahead and fill the pump body up and the suction line up to that priming port that I created. So I would strongly encourage that you incorporate a T on the discharge of these pumps if you don't have a dedicated priming port. And it's also important that when you prime a pump that we get all the air out of there, right? All the air bubbles. So we want to fill that pump body up completely and all the way out to the lake, the well, the cistern, wherever that suction line is going to go. We want to make sure we get that all primed. Anyway, there's 4 above ground pumps that we talked about today. The difference between a shallow well and a jet and a deep well jet is you got one line going to the water source or 2. And the difference between a straight centrifugal and a self-priming is where is that suction port located? Is it dead center or is it high up above? Therein lies all the visual differences that you need to be able to tell one pump from another. All right, I think that's probably coming down to the last portions here. Again, if you have not done this, please subscribe to our YouTube channel where you can find all these feeds. And check out Flint and Walling on social media. They're doing a fantastic job with social media posts, just letting you know what all is going on up here. But with that, I'm not sure, did I leave anything out? I'm not thinking I did, but hey, we're going to be back very soon with another broadcast and another topic. So grab that coffee on your way to the office, on your way to the job site, and cheers.